Hello, hello. In this video, I will show you how to do your finite element analysis for your Lab 2 of Mechanics of Materials. So first, open your SolidWorks and click on New Part. I open it in advance because it takes a bit time for me. I will say first steps. Let's save this part. So save as and save your part. And remember that you need to put your name in the part. Remember, I'll let you know that you need to put your name on the part. So ECE 215 Lab 2 and my name, I will call that V2. That's my second time doing it, at least. So you have your name. I want to see your name there when you submit your pictures. Another thing, we will work in millimeters. So click on your units and change them for millimeters, grams, and seconds. Okay. I will do my first sketch in the top plane. You see the pictures, so you are in sketch, new sketch. And what I like to do, I like to center all my parts. You don't need to, but me, I always doing that. So I'm doing a square. And after that, I will select construction line. And I will go from there to there, from there to there. And because I was on the right place, I think I'm already right in the middle. I'm not right in the middle. So enter, enter, and I will select the center of my um, referential and the center of this line, and I will put them coincident. Okay, I think this one I still need to select that one. Where is my center? I don't want to use the line, I want to use the points on there. So these points, and I need to find the center of this line that is just there too. And I want to make them coincident. So what happened now is like my rectangle is centered on my referential. So you see if I move that, I move everything. For the dimension, what I recommend, instead of putting the dimension directly on my sketch, I will create some equations. So you go on Tools, and oops, it's under Equation. And I want to create a parameter for length. Let's say mine is 100. A parameters for the width of my part. And there will be the 2 dimension that I have for this sketch. Okay. Let's do right away the thickness of the part. That will be for my extrusions. I could adjust TH because it doesn't take thickness, and I will have 10. So for your value, please put something different. Okay, we need something different. So enter, and now on the left on my tree, I have equation, I have those 3 parameters. Now in my sketch, I can put the dimension. And there's plenty of way of doing this part. Okay, maybe you did another sketch on the other directions, that doesn't matter. Okay, so this dimension will be, you type equal, and you go grab equal variable, the length, enter. Don't forget to click on enter. You need to see this little sum sign in front of it, otherwise it didn't take the parameter. And this one, I click on equal, and I go grab the width. So I'm seeing my part from the top view. And enter, and again I have my little sign. I'm done with the dimension, so I click enter. And I can go, before I exit my sketch, I can click on features and extrude my part, so it knows which sketch to extrude. You can also do the extrusions and after select the sketch, doesn't matter. Here, instead of tapping 10, you click right, equal, or click right, or just do equal, global variables, and select the thickness. So the beauty of that is like if you change the thickness just there, that will automatically update your part. Okay, don't forget to save. It's good to save sometimes. And now I need to do a holes on top of my part. So I want to do a sketch there. And oops, okay, I should have clicked on the plane first. And now sketch. And there's this tool there to make a straight hole, straight slot. You don't need to create two circles and line and all of that. You have the straight hole that is already there. So this is this type 1. So you see the 1, 2, and 3, that's the order of your click and what you will define. So that will define the first center, the second center, and after that, the radius of this part. So I want to stay aligned with the center. Ideally, I put right in the middle. I don't know if I will be able to. I don't. Another one, so click number 2, and now I define the number 3. And I can click enter. For this dimension, I also want to create parameters. So go back on your tools equation, and I will add a new variable that will call all length. So let's say this one, it has to be smaller than the length. I think I put 60 in my sheet. Don't remember. Will do. And the diameter of the hole. Diameter of the hole. So let's say my diameter, it should be smaller than the width, obviously. So let's say this is 30. Okay. And all those dimensions are millimeters because my my settings of the units in this part design is in millimeters. And you click on OK. I need to check first if this one is in the middle. I think it's not in the middle. So I will, yeah, it's not in the middle. You see the middle of my line is next to it, but not. So I click on this one, control, second one, and I put them coincident. So now it's in the middle. Remember, your sketch must be black. So now I need to add the length of the hole. And I click in equal, go grab the global variables or length, enter, or the check mark, green check mark. And I need to define the diameter. Oh, why is it not? Okay. I did something, I don't know what I did. Okay, so you see it's a radius. So don't forget when you will double click on this one, you will select your global variable. Your global variable equal, global variable diameter. But because it's a radius, don't forget to divide by 2 after. It will make the calculation automatically. And enter. And enter. And you see now, like, what we see, like, the parts looks a little bit small. Like, here, it looks like there's not a lot of material, so I will probably do this 60, a little bit smaller. 60 plus 15, so this is 15, 15, 30, 90. Yeah, we have just 5 millimeters left on both sides. That's not a lot. Before I exit the sketch, I will go on features and do my extrusion cut, my hole. And you can do, instead of this one, you can do through all. So whatever the dimension change, it's the hole always go through. Here we go. Let me do the length of this hole a little bit smaller. So I can double click on this one. Okay, if I cannot double click, I will go on equations and make my hole length maybe 40. Here we go. Okay. Okay, this is my part. Before we are going to do the finite element analysis, let's save. Okay, so one more thing that we need before we do the finite element analysis in the parts feature, we need to apply a material. So click right on materials and edit materials. You can just click on one of them that will apply to it, but we need to grab some information anyway. So you go on edit material, and there you will pick the material that you want. And let's say I'm taking I think I take 6061 alloy, and there's different one. And here, make sure you are in SE units. You see you have the different value. Oh, we could have used also the Newton time meter square, the Pascal instead of the megapascal. That will be good. Okay. Yeah, well, I will tell you to use that one. That's precise enough. I don't know if it's precise enough because if we put this one, oh yeah, that's the same precision. So let's go with units, international units, and in Pascal. You know what? Megapascal, because we have everything in millimeter, and we will keep everything in millimeter. So let's do that. You need to grab your elastic modulus, your density. I don't know why I asked you the density, but I asked you the density and the tensile strength of this one. Oh, we also have the yield strength. But because we are always only putting tensions, we can use a tensile strength. And you click on apply. Don't forget to click on apply. So MPA and apply. Yeah, it takes some time. I think I'm good. Here we go. You need to see there alloy your metal. And again, use something different than what I did. Um, so we can compare a little bit the different where the materials hold some tension. Okay. Now we want to create simulation. So here, simulation and new study. If you don't have this tab, click on the gear, add in, and check that you have the SolidWorks simulation check. Okay, and okay. You may have to like do it for the first time. If you do some dynamics, we need the SolidWorks motion. But for this one, the simulation. So here, okay. We will do a very simple static study. So static, enter. Okay. And what we need to, connection is we have multiple parts, like an assembly, and we want to put connection between parts. We don't need that. Fixture, let's define a fixture. So we want to define a fixed geometry. And I want to grab this, not the line, but the things behind it. So let's this one. Enter lets me hope that I took the right one. So I do Control-7 to be in the right direction. Yeah, perfect. So I block like all the face on the bottom of the part, like not the bottom, on the back. Okay. And external load, I want to apply a force. I want to apply the force on this surface. So we are pulling on that surface. That will be in the other direction, so reverse direction. I want to pull, and I want to pull, let's say, 3,000 Newton. Okay, we need quite to pull hard to see something happening. So okay, and mesh. I think we can just click mesh and run. It's a pretty easy part. It will create like an easy mesh and run it. And I will show you how we can check what the mesh looks like after. So you let it run. Oops. Depending on the computer, depending on the difficulty of the part, it can take more or less time. And here we go. We have some information over there. So first, if you want to see the mesh, you can click right. No, I think you click right on that one, and you click show, and you can see the mesh. So you see it makes some little triangle. So the finite elements, what we call finite elements, that's all these little elements. So this is one element, one element, one element, one element, etc. Okay. So what does that do is like it's apply the force on each point and spread it with a system of matrix because it's know the distance, equation of moments, equation of forces. That's how the force are spread inside the part, and we can know the stress at any point. Okay, so that's for the stress. That's for the mesh. Now you click on the stress, and you can see the stress. And what I want you to tell me is what are the, so there's a column with the maximum stress. That will be this one. Okay. So you see it's in Newton per meter square and not millimeter square. So this is Pascal and not megapascal. So check the units that I ask you to do. I think I ask you those units so it's a consistent with what we see. There's a huge deformations, but you see this scale there is time 376. So it's way more than what we can see. We can change that after. So what I want you to record is the maximum stress that you see is there, okay? I want you to record the minimum stress that will be somewhere on the surface. Okay, I know it's a little bit different, but you can grab something like there. So maybe 9.27 times 10 at the 6. And when I ask you so this one will be for the plane section. So the stress at the plane section, the strain at the plane section, etc. And when I ask you at the central section, I want it there in the middle. So where the section is smaller. So here, so for example, maybe 1.832 times 10 at the 7. Stress are higher here because the section is smaller. Okay. Remember, stress equals force divided by area. Smaller area, larger stresses. So you grab all those data and you put them in your in your spreadsheet. Displacement, I want you to grab, oh, well, how did I get the, I got the displacement on the right the last time. Let me double click again, see if that's coming this way. Oops. So you see here we can change the scale if we want. We can put true scale and I will put it at 1. Oops, and that will look like more normal. This one are the displacements. So the maximum displacement of your part will be not even 0.03 millimeter. Okay, 10 at the 2. So we are kind of safe. So this is the displacement. That's not the strain, that's the displacement, like the overall displacement. So of course here it does not move because it's stuck to the wall, but there that's where the part is deforming the most, has the most deformation. And after that you double click on your strain, and there it's a strain, so it's a percentage of deformation. So what I want you to grab is like the percentage of deformation around there, and the kind of in the middle. So for us, it should be the same everywhere there, but you see it's different because of this shape. And I want the strain in the middle there. So a strain at the smallest section. So maybe grab 2.809 times 10 minus 4, so it's not a lot, 0.02%, I think so, 0.002%. And one a bit lower there. Maybe grab something in the middle, like the blue one, like the 1.0210 at the fourth, at the minus 4. So that's everything you need for your from your data from there. If you are interested, you can create a report that will generate a Word with all the data information. And it may get my computer completely stuck. And after that, I will show you just your lab over there when it's working on my report at the same time. Okay, so put your name. This one is all about the geometry, so the parameter that you put at the beginning, the materials. Oops. Oh, it's creating my report. Okay, let me close that up. Let me go back on my report. So this one is the geometry that you pick, your material, the force I apply, this one, and the information about the material that you get into the material sheets in SolidWorks. Oops, I want to add something there. We'll see. This one are the result with SolidWorks, so the force that you apply, and this one is what you measure. This is not correct based on the new. I ran a new study, so it's different over there. I ran a study. This one was for the 300. So you fill all these things. The column where there is a divide by 0, you don't need to fill anything. I put the formula behind. I want to find the coefficient of safety. So when I put 300, that was a coefficient of safety of 50. We'll see when it's at 3,000. That should be probably way smaller than that, hopefully. And by end, I want you to find the area of the plane section, central section, the stress in the plane section, the stress in the central section, the strain in the plane section, strain in the central section, and the expecting max displacement. Okay, so me, I put some formula behind, but I want you to write your own formula on your report, and I want you to write your own formula in Excel. They should be different. This one, you don't need to do anything. That's the difference, the error from what you find in theory and what the SolidWorks finite element analysis found. Most of the mistake is coming like, where do we take exactly the value compared to what we have? But I'm curious to see all the data. I'm working again on this one. I don't think they are correct for now, but 20 seems like not too far, but this one looks far. But for me, the difference is coming like, do we take the value here or here or here? With the finite element analysis, we can see the concentration of constraints and all of that, which we don't take in account when we just look at the section. We don't also look at the fact that here it's progressively changing. Like I made it like it was just a square, etc., etc. So do that and use all those information and your calculations to fill your conclusion in your report. You have the templates in your instruction. So hope you have fun with these labs and let me know if you have any questions. Bye-bye.